I am going to be testing out Anomaly Detector. This is a cognitive service by Microsoft, an AI service that helps you foresee problems before they occur. Pretty cool. We all want to be able to predict the future, so why not? Let's try and check this out. Okay, straight into this. Let's look at the documentation, see what we have. Okay. Right, so I'm just going to go to this quick start. You know, I'm pretty impatient, so I'd like to get going ASAP. So let's look at using Python. You know what, I'm actually only going to test a single variable, see if we can find anomalies in a single variable time series. So let's start with looking at the univariate time anomaly detector. So all univariate means is that we'll be analyzing the time series with respect to one single variable. This could be anything. Multivariate just means that we'll use multiple inputs to feed the anomaly detector to algorithm. So, you know, you could look at the correlation between various signals, but in this case, we're just looking at one variable. Can we spot anomalies in a single variable time series? Okay. Seems easy enough. Okay, so let's look at the documentation here. Quick start, that's fine. Prerequisites, yes. Python 3 point whatever. I have pandas data analysis, yes. Azure subscription, we already have. You can create one for free if you don't. Okay, that's pretty simple. Setting up, okay. Create environment variable. Okay, so you don't have to do this. I'll show you a way in which you can actually get around, you know, doing this, or if you're unfamiliar with creating environment variables in your bash profile, you don't have to do this. Let's just go straight into creating a new Python application. Okay, so create a new Python file and import the following libraries. Okay, so let's fire up our VS Code here. Okay, let's just import those. That's fine. Let's just make sure we have no issues here. Run this. Okay, yeah, we're good to go. No errors. Okay, these libraries were imported just fine. You'll probably need to do a pip install on one of these libraries, so just watch out for that. Here we go. You probably just need to run this line if you're getting errors that you can't import this library. You just need to do a pip install. Okay, so object model. The anomaly detector client is a client that authenticates to Azure using your key. The client can do anomaly detection on an entire data set, blah, blah, blah. Fine. Okay, that's fine. So let's just copy this snippet. Get your subscription key and the endpoint. You'll need to head over to portal.azure.com. If you don't have an account, then just create one. Then you'll need to click create a resource. Again, anomaly. Yep, we go to cognitive services. We can go to, there we go, anomaly detector, create. Just create a resource. You can create a new resource group. You can, you know, choose a region and everything. I have already done this, so I already have a subscription key and endpoint to test, but if you haven't, you'll need to create this resource. Once you've done that, it's pretty easy to get your keys. There's a clear tab on the left which clearly states keys and endpoints. You can go grab your keys. So I've already done this, by the way, so I'm just going to skip this step. I have a file called request data, and if I open it, what you'll see is you see the first column contains timestamps in ISO 8601 format, I think that is, and the second column contains heart rate values, right? So the goal of what I'm trying to test for here is, can the anomaly detector tool detect anomalies in my heart rate? Because that is something that we want to flag, especially when we're providing, you know, ways to monitor your heart rate over time. You want to flag anomalies in your resting pulse rate. that could be an indication of cardiovascular issues. So our goal here is, can we use the anomaly detector endpoint to flag anomalies in an individual who's constantly monitoring their heart rate, because that could be a cause of cardiovascular condition. So in the first column, it's very simple. I'll zoom in. First column, I have timestamp. Second column, I have heart rate values. And you can see actually the last point, 120 beats per minute versus these other values which range between 40 and 50. That seems like an anomaly. Oh, this also looks like an anomaly as well. 90 beats per minute at rest, versus the other values. So let's see if the detector endpoint can pick those values up. So we'll define the path to that, and the path to that on my machine is this. Next thing we need to do is authenticate the client. Okay, so let's just copy and paste this. Okay, simple enough. And then we need to, okay, what does this do? Okay, so all this is kind of doing is getting your data ready to feed the anomaly detector client. So let's just copy this. Let's just put a comment saying prepare the data. Right, do we want to create a request? Note something important here is you need to specify time granularity. So these are different days where I've recorded heart rate values. This is the 8th of March. These are different days, so it's very important to specify time granularity. And mine's daily here. Okay, so let's. Okay, it looks like that's fine. No errors, which is good. Okay, so we want to now call the API to detect anomalies in the entire data set. So in the entire data set, can it detect if there's anomalies? There's different ways to do this, and we'll get on to the second one in a second, but let's just copy and paste this. Okay, so let's just zoom out a little bit. Okay, so this bit is actually detect anomalies in time. Yeah, the comments just auto-populate. It's crazy with GitHub Copilot. Okay, we've got an error here. So I don't know why that's anomaly detector error, but I'm just going to replace that with exception. That should be fine. I don't see anything wrong with that. Okay, so what this will do is it will get the response. If it's unsuccessful, we'll print some error codes. And if there is an anomaly in this response, it will iterate through these values and also print the index at which this anomaly occurred. So it sounds like a mouthful, but it's actually quite simple. Let's just go ahead. Okay, yes. So we got two anomalies, right? I showed you in the data sheet there were probably two values that were definitely anomalies, and we see here that anomaly was detected at index 23 and 46. Great, that sounds good. Now, what would be helpful actually if we just plot this visually so we can see where it's detecting anomalies. For that, I'm going to use. Let's just use GitHub Copilot here to help us plot this. Should be pretty simple. So let's just say plot the data file. Okay, yeah. This is just crazy. It's actually plotting plot data file 1. Okay, so we're going to use GitHub Copilot here to plot the actual data. So let's say fig x equals plt. Yeah, see, it just already knows. It already knows exactly what I need to plot. It's just crazy. Okay, and then set label time, yes. Value, yes. Beautiful. X. We don't want to show. So what we then want to do, okay, so it's now is now plotting just our simple time series chart, which is fine, but we actually want to show graphically where the anomalies lie. So let's see if Copilot gets this. Oh, even has plot the anomalies. I didn't even say that. Okay, for iris, yes. Wow. That is pretty awesome. And then axe. And then we can PLT to show. Okay, let's see if that works. Ah, beautiful. There we go. So we could see that this is the data file. So really this we shouldn't say value here. You know, for proper convention we should say beats per minute, resting beats per minute. And we can see that when plotting where the anomaly detector tool spotted the anomalies, we can see these are clear anomalies here. You know, clear signs of anomalies. Makes perfect sense, right? So you know, that's big green check for how this algorithm works. Next thing we want to do is they actually have a way which you can detect the anomaly status of the latest data point. Okay, so let's just check this out. Okay, so let's just do detect anomalies in the latest data point. Oh, you know, Copilot is trying to do it itself. Okay, so anomaly detect. I don't know why that's in there, but let's just get rid of that. Okay, so now what we're trying to do is so there's two methods in which you could use this service. You can either detect anomalies in the entire series, which is what I prefer, or you can actually detect the last point, which is given a stream of time series data, you'd only be inferring whether the last given point was an anomaly or not. So let's try that. So it's very obvious from the graph that the last point here is an anomaly. So this is the first method, which detects anomalies in the entire series, which is great. That's an anomaly. Also, that's an anomaly. And also we can see that the latest point was detected also as an anomaly. So there it is. I actually like the service. It's something we will use to upgrade our application, especially given the fact that we provide we effectively provide a tool to remotely access or extract physiological data. So we generate lots of data as a company, so therefore it's something we'll be looking to use to upgrade our service to predict health or abnormalities. So great, I like the service.